Good afternoon, ladies and gentlemen. Today we're going to be looking at Chapter 10.5. This is a chapter on surface areas of cones and pyramids. If you've not yet done Chapter 10.4, please do so first. That's the surface areas of prisms and cylinders. We're going to be looking at cones and pyramids this time around. A few terms for you here. First off, any regular pyramid is going to have a base of all equal sides. It's got a regular base. You know things like lateral face, you know things like base, you know things like vertex. A couple of new terms for you here. The slant height of a pyramid or a cone is going to be the distance upwards on the side of the pyramid or cone. So this distance, let's say from the base to the top going on the outside, is going to be called a slant height. The other new term that you'll see here, altitude. Think about climbing Mount Everest. What's your altitude? Or climbing up in the sky, what's your altitude? That's going to be the distance from the base to the top. It's also sometimes called the axis. The axis going from the base to the top when it's more rounded like this. Alright, sometimes you'll be given the altitude, sometimes you'll be given the slant height. You're always going to need to do some Pythagorean theorem by making a right triangle to figure out the other piece. So if we want to find the surface area of this rectangular pyramid, for example, we're going to start out like we did last class by making a net of this first. So we have a rectangular base. I know a square base. In fact, let's call this a square pyramid. I'm going to make a big assumption here that it's a square pyramid. I'm going to go ahead and make a net, drawing in all of the triangular lateral faces of this thing. And then I'm going to make a note that each of those lateral faces is 12 in slant height. And this rectangle is 15 on every single side. Lateral area now. Lateral area, well, if we find the area of just a single triangle, let's say first. Find the area of just a single triangle. Well, that's 1/2 base times height, so 0.5 times base of 15 times height of 12. All right, we can put that into our calculator here. 1/2 of 15 times a 12 is a 90. So we know that the area of a single triangle is 90. All right, 90 feet squared. If you want the lateral area, well, there are 4 of them overall in this figure, so 4 times 90. 4 times 90, you should know that off the top of your head. If you don't, think about circles for a moment. 90-degree angle, 4 of them, you're going to turn yourself into a full circle. It'll go around 360. This, of course, has nothing to do with degrees, but it's numbers you should know. 360 feet squared for our lateral area. That's the area on the inside here, 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 and here. Base area is not too bad. It's a square, so area is 15 squared. This little caret key you see sometimes is a squared. I know 15 squared, I believe, is a 225. Yes, it is, according to my calculator. So area is 225. Surface area. Every single problem in last chapter had to do with lateral area plus 2 bases. This is going to be slightly different since we only have 1 base. We can get rid of the 2. Surface area is lateral area plus base. So 360 plus 225 gives us a grand total of 585. 585 feet squared for our surface area of this figure, with a 360 lateral area and a base area of 225. Now we can do this with, let's say, hexagonal pyramids as well. You can certainly do that with hexagonal pyramids as well. We can go ahead and draw in a hexagon first, and we can draw the appropriate triangles coming off of each side. Alright. I noticed that the slant height of one of these triangles is 7, and I noticed that the base is a 4. So we could say that the area of one of these triangles then is 0.5 times 7 times 4. 0.5 times 7 times 4 is a 14. So then the area, the lateral area, there are 6 total triangles. 1, 2, 3, 4, 5, and 6 total triangles. So we're going to do 6 times of 14. That's going to give us a grand total of 84. 84. Lateral area is 84 meters squared. All right. We have that now. Now the tough part, we need a base. We've done these bases several times though. We all know that if we go ahead and connect a few of these, just like notes last class, connect a few of these up, a few of these pieces all together, we're going to have a 30-degree angle, a side of 2. So just like last class, we'll go ahead and do tan of 30 degrees is equal to 2 over our apothem, opposite over adjacent, 2 over apothem. Swap these two out, apothem and tan 30, because one's on the top, one's on the bottom. Think about cross multiplication. If you have cross multiplication, you have the tan 30 up here and a down here. It doesn't matter if you switch these two. You're still going to get the same answer. You're still going to cross them the same way. So we really just get apothems equal to 2 divided by tan of 30. And if we toss that into our calculators here, 2 divided by 30, tangent of that, 3.46. Apothems equal to a 3.46, and that's meters squared. 3.46 meters squared. This last little bit, surface area, well, I suppose I need the base area overall first. I'm going to go ahead and switch that to some orange here. Base area is going to be 1/2 times the apothem, 3.46, times the perimeter. It's 4 on each side. 4 times 6 gives us a 24. 24, so our base area overall times 0.5 times 24. Base area is a 41.57. So your overall surface area then, add those up. 41.57, add on the 84. That's going to give us 125.57. 125.57, I should put on some units there, meters squared. Excellent. We found the surface area of this figure. And we have these equations that I'd like you to write down. Lateral and surface area of a cone. Lateral area of a cone, you're going to use this formula right here. Lateral area is pi RL. All right, pi times radius times slant height. Slant height, for some reason we'd write slant height as an L. I don't know why. Every single geometry book does though, so we're going to keep with that. It says cursive L. Surface area, on the other hand, of a right cone, we're going to write as the lateral area plus the base. We all know that the base is just pi r squared, right? And lateral area is pi RL. So we'd say surface area is pi RL plus a pi r squared. For this cone right here, I see that we have a radius of 5 and a height of 12. If you remember from your Pythagorean triples, slant height then, it's a 5, 12 something triangle. This in fact is a 5, 12, 13 triangle that you can verify with Pythagorean theorem pretty readily. The lateral area of this figure is pi times r times L. All right, so that's pi times 5 for radius times slant height of 13. 5 times 13 times a pi. 5 times, let's put that in the calculator, 5 times 13 times pi gives us 204.2. 204.2. Base area, that's just pi r squared, so pi times 5 squared. 5 squared is 25, so we're literally just looking at 25 pi is a 78. .54. Surface area, go and add those together. 204.2 plus 78.54. It's going to give us a grand total of a 283.04. That's going to be in feet squared. All right. That's about all I've got for you today. Your assignment is on your homework calendar. I believe it is a mid-chapter study guide. So give that a shot, see what you can do. As always, bring some questions to class next time, or you can always email me with questions if you'd like. Have a delightful day.